Now we will discuss about the Bentham and Hooker system of classification. Why I have written the understanding of the Bentham and Hooker system. Understanding just it is not to study the classification, but to understand how the plant kingdom has been classified. The Bentham and Hooker system is a natural system of classification based on the natural characters. Before proceeding to the system of classification, we have to know first that what is the taxonomy, why we are going to study the system of classification. If we are not knowing the taxonomy, then what the use of the studying the classification? What is the taxonomy? Taxonomy is actually the pedestal of the entire biology. You can say the taxonomy is the pedestal upon which the entire biology is built. Without knowing the taxonomic importance or the taxonomy or the plant morphology, we cannot study different aspect of the plant. If suppose we are doing the research on the some physiological aspects of the plants or the anatomical study of the plant, then first we have to identify the plants. If we are not knowing the plant, then how would we can say that I am studying, I am doing research on this and this plant? Correct identification is the plant of the plant is very much important. So first you know what is the taxonomy. Taxonomy includes the identification, classification, and nomenclature of an organism. So taxonomy includes the identification, classification, and nomenclature of an organism. Though, how would you identify the things? If we say that if lion as well as cat entering into the room at the same time, so I think that you would definitely able to identify that which one is the lion and which one is the cat. Why? Why you would able to identify? Because you are having certain morphological characters in your mind, and you immediately you would apply that characters, that the lion would have these characters and the cat would have these characters. So you would be able to identify just after seeing in the fraction of seconds after seeing the morphology of that animals who is entering in the room. So play that important role. On that basis we can identify the things. And the classification we can classify the things on the basis of their utility, on the basis of their morphology. Though the morphology is important, but their utility is also important. Suppose a different type of writing material, we can say there is a group of the things which the group of the articles which having the ball pen, G pen, chalk, etc., etc. So how do you classify the things? You would classify on the basis of their utility. The chalk can be used for the writing purpose on the blackboard, while the ball pen can be used only on the paper writing. So you cannot write with the ball pen to the blackboard or the chalk to the copy or the paper. So there is a definite way of utilizing that material. So on that basis you can classify on their basis of their utility. If further I said you have selected the chalk from the group of the writing articles, if you have selected the chalk, and I said that further you have to classify this chalk. So what character you would select? You would select the different colors of the chalk. There is a pink color, there is a green color, there is a blue color, there is a white color. So you have selected colors. On the colors basis you have sorted out different pieces of the chalks. If further I said that you have to classify, then what character would you select? Then you have to select the size of the chalk. there is a different size in that group. So you would select the different sizes of the chalk material. So on that basis, you can classify the chalks. And the most important thing, the naming of the plant. So if you have studied the morphological characters, on that basis you can name to a plant. So naming is the most important thing, and there is a definite rule for the naming that is governed by the International Code of Nomenclature for plants, algae, fungi, and plants. So that is another chapter. Here we are discussing the Bentham and Hooker system of classification. So if I was focusing that the Bentham and Hooker system is the natural system of the classification. Why it is called as the natural system of classification? The natural system, the characters which are present in the plant is selected for the classification. Natural characters which are still visible in the plants, that character are selected for classifying the plant kingdom. Okay, then the Bentham and Hooker, if we go through the history of the Bentham and Hooker system of the classification, Bentham and Hooker was the Britishers. They worked together. Bentham, George Bentham, we can say George Bentham, and Sir J.D. Hooker. The George Bentham was born on 1800 and died on 1884, while the Joseph Dalton Hooker was born on 1817, while died on 1911. They worked together. They were the Britishers. They worked together at the Kew Garden. They worked together at the Kew Garden and proposed a system of classification. Became the director of the botanical garden, and where his father William Joseph Hooker was also the director that time. And after that, the Dalton Hooker became the director of Kew Garden, and he sent many workers, many botanists to different part of the world who collected the different plants, and he himself visited to different countries and gave the classification of the plant kingdom in the form of the he wrote a monumental work named Genera Plantarum, and this Genera Plantarum was published during 1862 to 1883. And the system of classification includes 97,205 species belonging to the 7,569 genera of 202 families. Then outline of the system of the classification. Though he divided the plant kingdom into two groups, that is the cryptogams and phanerogams. Cryptogams, where the reproduction is hidden. All the pteridophytes, you can say the ferns, are included in the cryptogams, algae, gymnosperm, etc., which are non-flower producing plants, you can say in a broad way, non-fruit producing plants. So we are not dealing with the cryptogams, we are dealing with the phanerogams only, that is the flower producing plants. And the phanerogams is further divided into three classes: dicotyledony, then the monocotyledony, and in between the dicot and monocot, there is the gymnosperm. Though the gymnosperm doesn't have any correlation either with the monocot or with the dicot, but has been placed in the mid of the dicot and monocot. This is the one of the demerit of the system. We will discuss it after. If I said that you have to identify the dicot as well as monocot. If I provide you the root of the dicot, then how would you identify? Either it is if the section of the root, TS section of the root, then you definitely able to identify because of the number of the vascular bundles. And if the stem section is given, again you they on the basis of their arrangement of the vascular bundle, they are readily arranged. In the monocot, they are scattered in the because the cambium is there. In monocot, the cambium mostly, except a few cases, the few exceptions are there where the cambium secondary growth is there. Otherwise, the secondary growth is absent. While in the most of the dicot, that is secondary growth. So the vascular bundles are arranged in a radial way. So you would able to identify whether you got the stem or you got the root. If I provide the leaf, then how do you identify? You have to identify only on the basis of the venation. In case of the dicotyledony, except few, that is the calophyllum. Calophyllum is the dicot but having the parallel venation. Otherwise, all the dicots will have the reticulate venation, while in case of the monocot, all the monocots will have the parallel venation except the smilex. The smilex is the only monocot which having the reticulate venation. Otherwise, all the monocot having the viral venation. So, on the basis of the leaf venation, you can identify that this one is the dicot and this one is the monocot. Then, if I provide you the flower, so would you able to identify the flower, which one is the monocot and which one is the dicot? All the dicot flowers is tetra or pentamerous, while in monocot it is always trimerous. Trimerous, merous means all the segments, all the group, either it is the stem or it is the sepals or it is the petals or it is the androgyme or it is the carpel. All segments will have the 4 or 5 or the multiple of that. If I said the tetramerous, then the calyx would be 4, the petals would be 4, then the carpels would be 4, the stigma would be 4, or it may be of multiple that. In case of the monocotyledony, if it is the flower is the trimerous, so all the perianth or it is the sepal or petal, whatever it is, that will be of 3 numbers and or multiple of 3. So on the basis of either you got the leaf or you got the flower or you got the stem or you got the root, you would definitely be able to identify whether it is the dicot or this belongs to the monocot. At this stage, you would able to identify in the plant whether it belongs to the dicot category or it belongs to the monocot category. If it is dicot, then you have to move further. It is the dicot is further divided into 3 subclasses, that is the polypetally, gymopetally and monoclamidy. How would you identify whether it is the polypetally or it is the gymopetally or it is the monoclamidy? So, in case of the polypetally, the petals would be free. And in case of the gamopetally, the petals would be fused. And monoclamidy, the tepals or petals either would be free or would be fused. What would be the petals free? This is, suppose these are the petals. These are the five petals. If it is not attached at the base to the each other, if it is free like that, then we would call it polypetally. If it is fused, it is united. You can say it is united like that. Then we would say the gamopetally. And in case of the monoclamidy, here it would be the tepals. Tepals means it is the unit of the perianth. So perianth either free or fused. Then in both the conditions, if it is perianth, either it is free or fused, then we have to place it in the monoclamidy. Then the polypetally, if it is polypetally, then it is further divided into the thalmiflory, disciflory, and calciflory. Here we can judge the position of the ovary in relation to the thalamus. Here this character you have to apply the position of the position of the ovary in relation to the thalamus. So what is the position? If the thalamus is flat, if the thalamus is flat and ovary occupies the top position, then all the flower parts are arises from the base of the ovary, then we would say that it is the thalmiflory. In case of the disciflory, the thalamus would be of disc shape. If suppose in case of the mango or in case of the citrus plants, the you can say the cushion-like structure present at the top of the mango. That is what? That is the actual. That is the disc-shaped thalamus. So we can identify the position of thalamus in relation to ovary. On that basis, we can identify the thalmiflory, disciflory, and calciflory. In case of the calciflory, the thalamus would be of cup shape. Cup shape. Thalamus will be of cup shape. If in case of the thalmiflory, though the thalamus would be of flat and the flower would be of hypogynous, ovary will be superior. Definitely ovary will be superior because it occupies the top position. In case of the disciflory, the flower again will be of hypogynous, ovary will be of superior. While in case of the calciflory, it is perigynous or epigynous, and ovary it is half superior or half inferior or completely inferior. Hypogynous, suppose this is the flower parts and the position of the ovary is occupies at the top, and all the flower part, these are the sepal, petals, androecium, etc., etc. If this system, these parts arises from the base of the ovary and ovary occupies the top position, then we would say it is hypogynous. The flower is the hypogynous. If evolution is going on and it reaches up to the mid of the ovary, then the flower would be of perigynous. And if the ovary moves downwards, this All the flower parts arises from the top of the ovary. This is the ovary. Ovary occupies the inferior position. All the flower parts arises from the top of the ovary. So it would be called as the epigynous. Hypogynous, perigynous, and epigynous. So in case of the epigynous, the ovary will be of completely inferior, while in case of the perigynous, it is half superior and half inferior. While in case of the hypogynous, ovary will be of completely superior. So on that basis, we can identify the thermofluory, discifluory, and calcifluory. In case of the thermofluory, we would have the certain orders, that is the perietals, renals, perietals, polygynini, caryophyllini, and gutiferi, as well as the malveals. In case of the renals, the most of the families, or you can say the plants, is of mostly herb and found in the moist places, or in, you can say, the wet places. The members of in the mostly marshy lands. And in case of the perietals, the Papaveraceae as well as the Cruciferae. Papaveraceae, Cruciferae is important families. And though if I said that you have to identify the Cruciferae, how would you identify? In case of the Cruciferae, there would be cruciform corolla. Corolla would be of cruciform. Why it is cruciform? It is resembles with the crucifixion of Jesus Christ. That's why it is called as cruciform corolla. So all the members of the cruciferae, it is another name of the cruciferae is Brassicaceae. It is also called as the Brassicaceae. So, in case of the Brassicaceae, the cruciform corolla would be there, and we can identify on the basis of the cruciform corolla as well as the tetradynamous condition of the stem. What is tetradynamous condition? The outer two stamens short, while the inner four long. If such condition is found, then it will be called as tetradynamous condition. It is the peculiar character of the cruciferae or the Brassicaceae, you can say. And another character, most important character of the Brassicaceae, we can identify on the basis of the fruit. Fruit will be of either silicula or siliqua. Most of the members having the siliqua, while in case of the Iberis amara, that is called as candiduft, it having the silicula. Silicula, how do you remember the difference between the silicula and siliqua? Fruit. This fruit is the characteristic, peculiar character of the cruciferae family. So how do you remember the silicula? Which one is the silicula and which one is the siliqua? In its very rough way, you can remember it. LA. It is ending with the LA. LA. L stands for length and A means absent. I'm telling you, the rough method to remember the difference between the siliqua and silicula. LM length is absent. It means the fruit will be broader than the length. If it is three times broader than the length, it will be called as silicula. If the length is more than the width, then it will be called as siliqua. That is the difference between the silicula and siliqua. So this character is the most important for the identification point of view in case of the crucifery. And papaver. How do you identify the papaver? These are the important some general families you should know about that family. It is in detail in your syllabus, so you should know the characters of the papaver. How do you identify the papaver? The papaver, that is the only on the basis of the only one character. On that basis, you can identify the papaver. There is no need to go through another character. If the petals are crimpled petals. Crimpled petals. How do you know the crimpled petals? Suppose this is the one petal, and in case of the papaver, there are the five petals. This much size of the that suppose this much size of the petal and this much size of the bud. So if I said that you have to arrange this size of the petal into this size of the bud, it has been arranged. When the flower is open, the petal will be also open, and it will be when it will be open, it will be of like that. All the impressions of their foldings still remains over there, whatever it is. If such foldings are there present in the petals, then it will be called as crimpled petals. Now it is clear? It will be called as crimpled petals. And this is the most peculiar character of the papaver. On that basis, we can identify the family. Another character of the papaver is the latex. No doubt, latex will be there, and that is not the family character. Most of the other family which having also having the latex. So on that basis, the basis of the latex we cannot identify. We cannot 100% sure that this is the papaver. But on the basis of the crimpled petals, we can 100% sure that this is the papaver. And another characters of the papaver, that is the what you call the peppery petals. Petals will be very thin, you can say the very thin petals will be there. That is called as the peppery petals. As well as one more character of the papaver is the caducus calyx. Calyx is the caducus. Caducus calyx, or you can say the deciduous calyx. Means that whenever the flower is open, the calyx will fall off. You cannot never find the calyx in an open flower. All the members of the Papaveraceae will have the caducous calyx or deciduous. Whenever the flower is open, the calyx will fall off. So these are the peculiar character of the Papaveraceae. On that basis, we can identify the family. Then in case of the Caryophyllene, we are also having the important family, that is the Caryophyllaceae. I'm telling only those families, highlighting those families which are in your syllabus, particularly how do you identify that families? As I said that the Bentham and Hooker system is the natural system. The why it is called as earlier I have told you, the character, the morphological character. On that basis, we identify, we classify the plants. That character present on the plants. So on that basis, we are classifying the plant kingdom. So if I said the identification of the Caryophyllaceae, then there must be some characters which must differ from the other family. So on that basis, we can definitely separate the Caryophyllaceae with the other families. So what are that characters? In case of the Caryophyllaceae, the most peculiar character are the Caryophyllaceae. Only on the basis of that single character you can say that this is the Caryophyllaceae. What is that? The free central presentation. Presentation will be of free central. Free central presentation. What will happen in the free central presentation? Suppose this is the ovary. Okay, this is the ovary wall, and this is the central position. The ovules are arranged on the center, and no doubt it is free. Free, it doesn't have any attachment with the ovary wall. It doesn't have any attachment with the ovary wall. It is free. That's why it is called as free central presentation. If it has septation, or you can say the attachment with the ovary wall, then the presentation would be changed. It will be called as axial presentation. If it doesn't have any attachment with the ovary wall, then it will be called as free central presentation. In case of the free central presentation, the chamber would be of only one. Only one locule will be there. If the septation is there, then the chamber would be of 4 or 5, whatever it is. Then it will be pentalocular or tetralocular. While in case of the free central, it will be of unilocular. Only one locule would be there. So that's why it is called as the free central presentation. In case of the Caryophyllaceae, the free central presentation would be there. Well, in case of the Guttiferi, there is no particular family in your syllabus. So just you have to go through it. And in case of the Malvaceae, there is one family in your syllabus, that is the Malvaceae. And the Malvaceae, it is very easy to identify that the Malvaceae. that how would you identify the Malvasi? Since ninth class you are studying the Malvasi family. In case of the Malvasi, what will be there? How will you identify? First of all, the free lateral stipules will be there. Free lateral stipules, that is one of the character of the Malvasi. Then mucilage will be there. Mucilage will be there, and further, the most peculiar character on that basis you can say that this is the Malvasi and none of the other family, most probably in your course, which have the such character. The reniform stamens. The lobe and the lobe is of, it is like that. Reniform. Reniform antherlobe. So all the members of the Malvasi will have the reniform antherlobe, as well as the dehiscence is transversely. The he from where the pollen grains liberated, it dehisces the transversely. So all the members of the Malvasi will have the free lateral stipules, reniform stamens, as well as the mucilage will be there, and one thing more, that is the you can say the style. Stigma is free, while the style, all the styles are free. That passes through the staminal tube. So style passes through the staminal tube. It is also one of the character of the Malvasi. So on these basis, we can identify the family of the Malvasi.